So using the dataset BMD drug, we now want to study the association between categories of BMI and risk of fracture. So you should have created the variable BMI in the lecture, and we'll now want to categorize the variable BMI, creating these three categories: under 25, 25 to 30, and higher than 30. And once we have these three categories, then we want to study its association with the variable fracture. Okay, so we're going to do this. We're going to, again, using the dataset BMD drug, we're going to recode the variable BMI, which is here at the bottom of, at the end of the dataset. So let's go ahead. I'm going to do transform, recoding to different variable. The variable that I'm going to recode is BMI. Let's give a name to the new variable. Let's call it BMI cat from categories. And the label can actually write groups of BMI. Change. And now let's tell SPSS how to do the transformations. And the transformation is going to be anything that is system or user missing, it's going to stay as system missing. And now from the lowest value up to 24.999, so right up to 25, it's going to be coded as category 1, add, and then between 25 and 30, it's going to be category 2, add, and then from 30.001 up to the highest value of BMI, it's going to be category 3, add, continue, and OK. So we have now a new variable that refers to the categories of BMI. I'm going to create just the labels for the categories. So by clicking twice in the variable, I come to the variable view screen, and now I can go to values and say that value 1 is less than 25, 2 is from 25 up to 30, and number 3 is higher than 30. So this is just for me to know exactly what 1, 2, and 3 means. Okay, so now I have the variable BMI cat. I also have another dichotomous variable, which is going to be the fracture, and I want to study the association of these two variables. So I'm going to ask SPSS for the table, the cross tabulation, so descriptive statistics cross tabs, and I'm going to do reset, something here before. So I'm going to ask for hip fracture to be in the columns and the BMI to go on the rows, okay? And if I do okay right now, I'll just get the absolute values, which are not that useful. So I want also to ask for some percentages. And I want to see within each category of BMI what is the prevalence of fracture. So I'm going to ask the percentage by row. So I'm coming to cells, and I'm going to ask for percentages by row. Continue. And because I want actually to see if there's a statistical significant association between the two variables, I'm also going to ask for the chi-square test. Continue. Okay. And here we have in the output, so the lowest BMI group has the higher proportion of fractures, 8% versus 2% in the other two groups. Okay, so it's not surprising that we actually have a statistical significant association between those two variables. but in fact you can see that there's a few low values in some of the cells of the table. This might invalidate the approximation used for the Pearson chi-square test. So actually I could repeat the same procedure but ask for the Fisher exact test. So I'm going again to what I've done before, cross tabulation, but now in the exact I will ask SPSS to perform the exact tests. Here, continue and OK, and I should have the Fisher exact test, which again is statistically significant, less than 0.05 or 5. Okay, so we can conclude that the data presents evidence that there's an association of group of BMI and risk of fracture, where the slimmer group will have an increased risk of fracture. Of course, we're not adjusting for any other potential confounders. This is just the two-way association between these two variables.